question 3, we are trying to find chemical formulas from names of different compounds. So it would definitely be useful on this and many of the other problems to have a periodic table nearby that you can refer to while we work through these problems. Also, in order to do these problems, you do need to know the nomenclature for all of your polyatomic ions. So we can start with magnesium. Magnesium we find in the second column of the periodic table. We know that it generally gives us a +2 charge. Sulfate is one of the polyatomic ions that we need to know. Its formula, SO4 2-. As the charges here are equal but in opposite signs, we need 1 magnesium for every sulfate. And so our formula for magnesium sulfate is MgSO4. For rubidium iodide, rubidium we find in the first column on the periodic table. Gives us a charge of +1. Iodine is in the next to last column. It's one of the halogens. That group normally gets a charge of -1. So we need 1 rubidium and 1 iodine. Part C, we're looking at sodium sulfide. Sodium, Na. In the same first column as rubidium, so also a charge of +1. Sulfur, we find generally gets a charge of -2. As you may recall, one of the methods we use for determining how many of each element or each group we need is to switch the numbers for the charges for the number of each element that we need. So given that sodium is +1 and sulfur is -2, in order for these to be balanced, we need 2 sulfurs and 1 sodium. Finally, in part D, we have 2 polyatomic ions, ammonium, NH4+1, and phosphate, PO4 3-. As before, we use our method of using the charges to determine how many of each element we need. In order to balance our charge, phosphate is -3. We need a total of +3 to balance that. And so that means we need a total of 3 ammonium ions combined with a single phosphate, gives us a neutral molecule and gives us our chemical formula.